Hello everyone, welcome to the RCNP course. Today we're going to introduce the VLAN advanced feature. And the first topic is about the super VLAN. Let's see the background of it. In broadband connected hotels and neighborhoods or campus networks jointly built by operators and schools, users are highly concentrated. In these scenarios, Layer 2 isolation is required on the premise of Layer 3 communication. And as we have already introduced, to isolate the Layer 2 users or to isolate the broadcast domain, we can use the VLAN technology. But it's impossible to configure an IP address for every room or VLAN because of limited IP addresses. So we need another technology to do the Layer 2 isolation. And what we are going to introduce here is the super VLAN. A super VLAN contains multiple sub VLANs used to isolate the broadcast domains in a physical network. The sub VLANs can use the same IP subnet and default gateway to reduce the IP addresses usage. And for the super VLAN technology, there are two different VLAN rules. The first is the super VLAN. Super VLAN is used to create Layer 3 SVIs and configure the sub VLAN gateway IP address. The super VLAN contains no physical ports, while the other one, sub VLAN, contains only physical ports and are used to isolate Layer 2 broadcast domains. The ARP proxy function needs to be enabled for the super VLAN and sub VLANs for communication between hosts in a sub VLAN and external hosts, or the communication between sub VLANs. So from here, we can know that super VLAN only works as the gateway of the terminals, while sub VLAN is the actual VLAN that are used to, for example, encapsulate or decapsulate the frames in the network. After knowing the difference between these two rules, then let's see an example. Now we have three VLANs, sub VLAN 10, sub VLAN 20, sub VLAN 30. Even they're sub VLAN, but they are different VLANs. So different VLAN indicates different broadcast domain. So by using the sub VLANs here, we can isolate the whole network into three different broadcast domains. Broadcast domain 1, broadcast domain 2, and broadcast domain 3. Okay, and next is the subnet, or the terminals, or the PCs in these three VLANs belongs to the CM subnet, which is 192.168.1.0. Mask length is 24. CM subnet means they will have the CM gateway. So what's a gateway? The gateway address here is 192.168.1.1, which max length is 24. And pay attention here. The gateway address actually is the IP address of SVI2. And SVI2 is a Layer 3 interface, right? Or is the SVI of VLAN 2. So from here, we know that super VLAN 2 will create a SVI2 and will get an IP address to work as a gateway of all the terminals in the following sub VLANs. Okay, this is a logical architecture or the logical relationship between the sub VLAN and the super VLAN. Then let's see the communication, or how does the traffic forward it if we use the super VLAN technology. Firstly, let's see this figure. Now we have two sub VLANs, sub VLAN 10, sub VLAN 20, and inside each sub VLAN there are two PCs. Okay, and from the IP address in this figure, you can see all these PCs are in the CM subnet and have the CM gateway. So let's see how does the frames are forwarded in this scenario. it says that a sub-VLAN is a broadcast domain. Therefore, hosts in a sub-VLAN can communicate with each other. For example, here, these two PCs in sub-VLAN 10, they can communicate with each other. For example, the first PC will send a ARP request, and the ARP request is the broadcast frame. From the content inside, we can see that this ARP broadcast is asking for the MAC address of the IP 192.168.1.4, and it's the second PC in this figure. Since they are in the same broadcast domain, so this ARP request will be flooded, right? And the second PC can receive it. After receiving this ARP request, there will be a ARP reply. And after getting the ARP reply, the first PC will encapsulate the frame with the MAC address of second PC, and they can establish the communication between each other. And for the communication in sub-VLAN 2, actually it's the same. Okay, this is the communication within a sub-VLAN. And next, let's see the communication between sub-VLANs. For example, here, the communication between PC1 and PC2. Since PC1, PC2 are in two different sub-VLANs, so it indicates that they are in two different broadcast domains. If they are in two different broadcast domains, PC1 will firstly send out an ARP request. But the destination we can see, IP is 192.168.1.14 is PC2. But PC2 is in another broadcast domain. So actually, PC2 cannot receive this ARP request without any other features. So to solve this problem, you can see here we are using proxy ARP. After enabling proxy ARP, this switch will work as an ARP proxy and will forward the ARP request from PC1 to PC2. So in this way, PC2 has received it, right? Has received the ARP request from PC1, and of course, PC2 will maybe respond to this request. Okay, let's see. PC2 will respond it, and you can see the MAC address here is the MAC address of PC2. Okay, and after getting the MAC address of PC2, the switch, you can see, switch has enabled proxy ARP. So based on the working principle of proxy ARP, actually, the switch will replace the MAC address in the ARP response to be the MAC address of the gateway, actually. Actually, it means that the switch tells the PC1 that if you want to send a packet to the IP address 192.168.1.14, you can directly send it to me. You can directly send it to the gateway, right? Because they are in two different broadcast domains. So all the traffic should go through the gateway. This is the reason why the switch directly give the MAC address of gateway to PC1, and PC1 will get the response. After getting the MAC address of PC2, right? PC1 will encapsulate the packet and send it to PC2. So let's see it. PC1 sends out a frame, and after receiving it with the physical ports, so the switch will tag it with a VLAN tag, which is 10, because PC1 belongs to the sub-VLAN 10, so it will have a tag 10. And this frame will be forwarded to the gateway, and the gateway will send it to the destination, right? So it will replace the tag and send it to the destination PC2. While before sending it to PC2, we should remove the tag, because as we all know that all the packets sent out through the access port is the untagged frame. So you can see this is an untagged frame, which is sent to PC2. Okay. This is the communication between PC1, PC2, which are in two different sub-VLANs. Okay, so for this process, let's make a summary. The following describes the communication between PC1, PC2 when proxy ARP is enabled for SVI2 of the Super VLAN. Okay, firstly, PC1 discovers that PC2 is in the same IP subnet and the ARP sheet contains no PC2's related entries. PC1 sends an ARP broadcast packet to request the PC2's MAC address. SVI2 of the Super VLAN serves as the gateway receives the ARP request from PC1. SVI2 is proxy ARP enabled, send ARP broadcast packet to all sub-VLANs in Super VLAN 2 and request the PC2's MAC address. PC2 in sub VLAN 20 receives the ARP broadcast packet from the gateway and responds to the request. The gateway receives the response from PC2 and sends the gateway MAC to PC1. And all subsequent messages sent from PC1 to PC2 will be forwarded by the gateway because the MAC address actually has been replaced to be the MAC address of gateway, right? So all the traffic will be forwarded by the gateway. Okay, this is the communication between two PCs in two different sub-VLANs. And the next, let's see the layer 2 communication between a sub-VLAN and common VLANs. Here, the common VLAN represents the PC3. PC3 belongs to VLAN 10. And here, it's just a common VLAN, not a super or not a sub-VLAN. And let's see the communication. The communication between a host in a sub-VLAN and external hosts is the same as a layer 2 communication in a common VLAN. Because the PC2 will send the packet to the SW1, SW1 will check the trunk link. You can see the trunk link between SW1 and SW2. Since the VLAN, which VLAN 10 is allowed, so this is allowed to forward the traffic from SW1 to SW2. And after receives that, SW2 will check the MAC address table, find the outbound interface G01, and before send out the packets, G01 will remove the tag. Right? This is the communication between PC1 and PC3. Devices carry no Super VLAN tag data because the Super VLAN does not belong to any physical ports. This is very important, since here we see that we have a Super VLAN, which is 2, but there will not be any frames carries the Super VLAN tag. For example, there will not be any frames that can carry a tag which VID is 2, because Super VLAN 2 do not belong to any physical ports. But how does the frames get their tag? The tags of frames actually is assigned by the physical ports. For example, when access port receives an untagged frame, so it will tag it with the PVID, tag with the PVID of the access ports. Or when a trunk port receives an untagged frame, it will also tag it with the PVID of the trunk port or the native VLAN of the trunk port. So each frame gets the tag from a physical port. Since the Super VLAN do not belong to any physical ports, so there will not be any frames carry the Super VLAN tag. Okay, this is a layer 2 communication between the sub VLAN and the common VLANs. And let's go. It's a layer 3 communication between a Super VLAN and the common VLANs. In the former case, PC1 and PC3 belongs to the same VLAN, which is VLAN 10. So it's a layer 2 communication. But here in this case, PC1 belongs to sub VLAN 10, PC3 belongs to VLAN 100. And you can see they're in different subnets, right? And actually, In this case, the communication between PC1 and PC3 is also similar to the layer 3 communication. Let's see the process. Firstly, PC1 will send out a frame, which source IP is PC1, destination IP is PC3, and the source MAC is the MAC address of PC1. Destination MAC, pay attention here, destination MAC, since we have enabled proxy ARP, so the destination MAC here will be the MAC address of the gateway. Okay, so it's you can see the destination MAC is SVI2 MAC address on SW1. In this way, this packet is sent to SW1, and after receiving it, SW1 will send it to SW2. So you can see the source IP, destination IP is unchanged, but the source MAC and the destination MAC has changed to be source MAC is a MAC address of G02 on SW1, and the destination MAC is the MAC address of G02 on SW2. Means we are forwarding the packet from SW1 to SW2, and after receiving this, SW2 will send it to PC3, and you can see the source MAC and destination MAC has been changed again. Source MAC is the MAC address of SVI 100 on SW2, and the destination MAC is the MAC address of PC3. And actually, in this case, we need to check the MAC address table. We need to check the IP routing table, right? Because this is a layer 3 communication. Layer 3 communication is based on route. Okay, so this is about the how does the packet forwarded when we use the super VLAN in the network. And the next, let's see the configuration of super VLAN. First step is to create VLANs and lambda VLANs. Here we have created VLAN 2, VLAN 10, VLAN 20, and VLAN 30. Right? Because from the figure we can know that the super VLAN is VLAN 2, and we have 3 sub VLANs, 10, 20, and 30. So we should create all these VLANs by using the command you can see on the left. And after creating these VLANs, next, setting VLAN 2 as a super VLAN and VLAN 10, 20, 30 as the sub VLANs. So you can see VLAN 2, super VLAN. This is the method to set the VLAN 2 as a super VLAN. And sub VLAN 10, 20, 30. So by using this command, we can set VLAN 10, 20, and 30 as the sub VLANs. And for the super VLAN, we should create the SVI, so interface VLAN 2. So we have created SVI 2 and configure the IP address of the interface SVI 2. IP address 192.168.1.1, and the mask is 255.255.255.0. So this IP address will be the gateway of all the PCs, right? And then next, configure sub-VLAN IP address segments. Here is the design of the IP address. For example, the IP address segment of VLAN 10 is from 192.168.1.10 to 1.50. And VLAN 20 is from 1.60 to 1.100. VLAN 30 is from VLAN 100 to VLAN 30 is from 1.110 to 1.150. Let's see how to configure it. Firstly, enter the configuration view of VLAN 10 and use the command here, stop VLAN address range 192.168.1.10. This is the start IP address. And 192.168.1.50, this is the end IP address. So you should know this. This is not only 2 IP, but it's a range. Okay, it defines a range from 1.10 to 1.50. And for VLAN 20, it's the same sub-VLAN address range 192.168.1.60, 192.168.1.100, and for VLAN 30, it's the same, right? Okay. After finishing this step, next, let's see, bind ports and sub-VLANs on the access switches following the procedure of configuring VLANs for ports. Interface G01, switch port access VLAN 10. Interface G02, switch port access VLAN 20. And interface G03, switch port access VLAN 30. This is just the common configuration of VLAN. Right? We just need to specify which VLAN does the physical interface belongs to. Right? This is the configuration on the access switches. For example, the SWB or switch B, switch C, switch D in the figure. Okay, and after finishing this, actually you have already finished the configuration of the super VLAN. So from here you can see actually it's not complex, right? The configuration of the super VLAN is not complex. Okay, but in some cases, the super VLAN has its limitations. Limitations means it cannot be used to solve some of the problems. So let's say it. The super VLAN contains only sub VLANs and no ports. Sub VLANs contain physical ports. A super VLAN cannot be a sub VLAN of other super VLANs. For example, sub VLAN 10 has already been the sub VLAN. For example, we have already created a super VLAN 10, so we cannot use VLAN 10 to be a sub VLAN of, for example, of another super VLAN, maybe super VLAN 20. Okay, and VLAN 1 cannot be set as a super VLAN. This is important. VLAN 1 is the default VLAN, and it cannot be set as the super VLAN. Sub VLANs cannot be configured with the routed ports, IP addresses, and SPIs. Okay. And super VLANs do not share sub VLANs. That is, a sub VLAN belongs to only one super VLAN. Okay. And sub VLANs cannot be deleted using the no VLAN command. Because normally, if we have created a specific VLAN, for example, we have created VLAN 10. So if you want to delete VLAN 10, you can directly use the command no VLAN 10. But if it's a sub VLAN, it doesn't work. How can we do that? Let's see. To delete a sub VLAN, restore it to a common VLAN and run the no VLAN command. Only in this way you can delete it. And the ACL queues configurations of a super VLAN SVI do not apply to sub VLANs. Okay, this is about the limitations of super VLANs. After finishing the introduction of super VLAN, next let's see another technology which is called private VLAN. And let's see the background. Just when we introduce a super VLAN, we said that we can use a super VLAN to do the layer 2 installation, right? And but some VLANs need to be isolated from each other. VLAN isolation cannot be implemented after proxy ARP is enabled for the super VLAN. So it means even we have used the super VLAN, so we cannot isolate the VLANs because we have enabled proxy ARP, so they can maybe communicate with each other at layer 3. Even layer 2 has been isolated, but they can communicate with each other at layer 3. So layer 2 isolation is required for some VLANs. Layer 2 isolation cannot be implemented for super VLANs. So let's see, how does the private VLAN works and how does the private VLAN to establish the layer 2 isolation in the network. Private VLAN divides the layer 2 broadcast domain of VLAN into multiple subdomains, each of which consists of one private VLAN peer. One private VLAN peer is consists of a primary VLAN and a secondary VLAN. All private VLAN peers in one private VLAN domain share the same primary VLAN. What's a primary VLAN? What's a secondary VLAN? Let's see it. For the primary VLAN, one private VLAN domain contains only one primary VLAN, while a secondary VLAN can be an isolated VLAN or a community VLAN. And inside one private VLAN peer, we could have more than one secondary VLANs. Okay, and next thing, for the secondary VLAN, the first type is isolated VLAN. Ports of an isolated VLAN cannot perform layer 2 communication. One private VLAN domain has only one isolated VLAN. So for example, VLAN 10 is the isolated VLAN. So all the ports belongs to VLAN 10. They are isolated at layer 2, means they are not allowed to communicate with each other at layer 2. Okay, this is a function of isolated VLAN. And the next is a community VLAN. Ports of a community VLAN can perform layer 2 communication with each other. Ports of different community VLANs cannot communicate with each other. So inside one community VLAN, layer 2 communication is allowed, or between two different community VLANs. For example, community VLAN 10, community VLAN 20. The users in these two different VLANs, they are isolated. They cannot communicate with each other. Okay, and one private VLAN domain can contain multiple community VLANs. Okay, this is about the different types of VLANs in the private VLAN. Next, there are three kinds of ports in a private VLAN domain. The first is the promiscuous port that belongs to the primary VLAN, and isolated ports that belongs to the isolated VLAN. Community ports belongs to the community VLAN. Right, it's quite easy to understand. So to make it more easier for us to understand, so let's see an example here. From this figure, actually we can easily understand the difference between isolated VLAN and community VLAN, and the difference between different port types. Okay. Now, here the primary VLAN of this private VLAN peer is VLAN 100. You can see primary VLAN 100. And except the primary VLAN, we have some secondary VLANs. For example, community VLAN 101, community VLAN 102, community VLAN 103. Okay. Except that we have a isolated VLAN, which VLAN ID is 199. So in this way, all the PCs, you can see all the PCs in the isolated VLAN are isolated. You can see they are isolated, means they cannot communicate with each other. Okay, and at the same time, the PCs in the same community VLAN, for example, these three PCs, they are allowed to communicate with each other at layer 2. They are not isolated. But the PC, for example, the PC in community VLAN 102 and the PC in community VLAN 103, the communication between these two PCs is not allowed. Okay, this is not allowed. This is the working principle of the private VLAN. And in this way, we can solve the problem that after enabling the ARP proxy, super VLAN cannot isolate the communications. And at the same time, this port, you can see this port is the promiscuous port. Promiscuous port is bind with the primary VLAN, which is 100 in this case. Okay. After knowing the private VLAN working principle, next, let's see the configuration. Firstly, configure the VLANs in the private VLAN and associate the VLAN with the private VLAN. So first command, VLAN range 101 to 103. So in this way, we can create 3 VLANs. And next, private VLAN community. So we are creating the 101 to 103 to be the community VLAN, right? And then create VLAN 199. Private VLAN isolated. So VLAN 199 is the isolated VLAN. Next, VLAN 100, private VLAN primary. So VLAN 100 is the primary VLAN. Next, private VLAN association, VLAN 1, 101, VLAN 102, VLAN 103, VLAN 199. So we are binding these VLANs to the primary VLAN 100. Okay, and after this, next is assign ports of switch SW1 to related VLANs of the private VLAN. Interface range G0123. G0123 means this reports, right? This reports in the figure. G0123 represents this reports in the figure, right? And let's see what we have done to these reports. Switch port mode private VLAN host. Switch port private VLAN host association 100, 101. So we are actually binding these reports with the community VLAN 101. And for G0426 is the same, but we are binding with different VLAN IDs, which is VLAN 102 in this case. And G07 is binding with the 103. Okay, this is a configuration on SW1. And next is SW2. Actually, the configuration is similar. Interface range G01 to 2. Switch port mode private VLAN host. And switch port private VLAN host association 100 and 103. Means these two ports, G01, G02, belongs to VLAN 103. And next, interface range G03 to 5. Switch port private VLAN host association 100 and 199. So we are assigning ports 3, 4, and 5 to isolated VLAN, which ID is 199. Okay, and after finishing the access ports on switch 1 and switch 2, next let's see is to configure the private VLAN interworking between switches SW1 and SW2. On SW1 interface G048 switch port mode trunk, and on at the same time interface G047, because G047 is special, it's connected with the R1, right? So switch port mode trunk, switch port mode private VLAN promiscuous. So by using this command, we can set the port G047 to be the promiscuous ports, right? This is important. You should remember this command. Okay, and the next is to configure the gateway. And here we use R1 to be the gateway in this case. On R1, firstly, we should create VLAN 100, VLAN 199, and VLAN 101, 102, 103. All the VLANs we use should be created on R1. And for VLAN 100, we should set it to be the primary VLAN. So private VLAN primary, and private VLAN association 101 to 103, 199. So we have associate VLAN 100 with the secondary VLANs, which are VLAN 101, 102, 103, 199. Okay, and next is the configuration of the gateway. Interface 100, IP address 192.168.100.254, and the mask is shown here. So this is the IP address of the primary VLAN, and at the same time it's a gateway, right? And the next, private VLAN mapping 101 to 103, 199. So we are mapping the two secondary VLANs to the primary VLAN 100. And interface G01 switch port mode trunk. Set the downlink access port to work in trunk mode. Okay, this is about the configuration of the private VLAN. Right? It's a little more complex than the configuration of super VLAN, right? But actually, it's not difficult to understand. So you need some practice to master the configuration here, right? Okay, so after knowing the working principle of super VLAN, next let's make a summary by maybe seeing some questions together. First question is that which of the following statements about Super VLAN is true. Choose A. All VLANs can be configured as a super VLAN. Obviously, it's false, right? VLAN 1 cannot be configured as a super VLAN. And B, proxy ARP needs to be enabled for the super VLAN if hosts in different sub VLANs need to communicate with each other. Right? Obviously, it's true, right? This is true. And C, sub VLANs can be deleted using the no VLAN command. This is false, right? Because for the sub VLANs, firstly, we should restore it to be a common VLAN and then use the command no VLAN to delete the common VLAN, right? And choose D, before configuring the SVI and IP address of the super VLAN, hosts in the sub VLANs can perform layer 3 communication with hosts in other networks. Actually, of course not, because the SVI or the IP address of the super VLAN is the gateway. Right? But without the gateway, it's impossible to perform the layer 3 communication. So here, the answer is B. Okay, and the next, which of the following statements about per VLAN is true? Let's see them. A, hosts in a community VLAN can communicate with each other, while hosts in different community VLANs cannot communicate with each other. Yes, it's true. Right? B, hosts in an isolated VLAN cannot communicate with each other. Yes, it's true. This is the reason why it's called isolated VLAN. Right? And C, hosts in an isolated VLAN can communicate with each other, while hosts in different isolated VLANs cannot communicate with each other. It's false. D, hosts in a community VLAN cannot communicate with each other. It's also false. So here we choose A and B. Okay, and next question. Which of the following statements about the native VLAN is false? A, when transmitted through the trunk, data that belongs to the native VLAN carries no tags. Yes, it's true. It's true because the packets belongs to the native VLAN means the VLAN tag is the same as the native VLAN. So in this way, before sending out this frame, the trunk port will remove the tag. So choice A is true. And B, for radius switches, the default native VLAN is VLAN 1. Yes, it's true, right? Because VLAN 1 is a default VLAN. C, when transmitted through the trunk, data that belongs to the native VLAN carries the tag of VLAN 1. It's false, right? It's false. Of course, they carries no tag. Here we choose C. Okay, so that's all. Actually, that's all for the content of this part. And let's make a summary together. By dividing a super VLAN into multiple sub VLANs, you can create layer 2 broadcast domains. Layer 2 isolation is implemented for sub VLANs, and communication between sub VLANs depends on the proxy ARP function of the super VLAN. Super VLANs with proxy ARP enabled cannot solve the problem of layer 2 isolation of sub VLANs, but per bit VLANs can solve this problem. Okay, that's all for this part. Thank you for your listening.